Hello guys, welcome back to the channel again. So in this video we will discuss the fifth question of August Leetcode challenge. So our question is add and search word, design a data structure. Now we have to design a data structure with which perform two operation, add and search a word. So first of all, the thing which we have to do is add word and then we will proceed for the search word. Now first of all, we will understand the question properly, then we will go for the solution part. Now for understanding, we will understand this question with the help of many examples. So first of all, we will try to understand that what we have to do in the question. So we have to first of all add a number into a data type. Suppose we add a B and C, and then many numbers can be added. Suppose A B C, A B D, and like this any number of numbers can be added. Now all will be in smaller or all will be in lowercase. Now what we have to do, we have to search this word. Suppose we get a word A, B and C. We have to search that this is present in this data structure or not. If this is present, then we have to return true, else we have to return false. Now the words any word can be replaced by a dot, or sorry, any word can be replaced by a dot. Suppose dot B and C. So this is what our question says, that any word can be replaced by the dot. So if in this case, if we replace it by the dot, it is also present in this, because dot represents any digit. Any digit can be A, B, C, D. So for that we just search this thing. So by seeing question till now, we understand that one data structure which is most favorable or which can be applied on this is try data structure. So the data structure which till now we have understand can be applied on this is try data structure. Now first of all, if you want to study try data structure in detail, comment it down, because I'm in this video I'm just going to explain the small part of it just for solving this question. Now let's see that what is a try data structure. Now suppose you have given some data types, or you have given some data, suppose A, B, C, D, any other variable B, D, any other variable C and E. Now I want to insert these all into a data structure. So how can I insert? So what this is? This is AD. Let's write it properly. So for A, B, C, B, C, A, D, E, and let's take one more A, D, E, R, and then D, E, R. Let's not take D, E, R. Let's take it D, E, F. Sorry, not D, E, F. What we consider it as D, H, T. So let's consider these four as our input, and then we will do for the searching part. So now we are just trying to build a try data structure with the help of this example. So first of all, I'm just going to explain that what is a try data structure. Now what try data structure do is, suppose you have inserted the first digit A, then B, then C. Now suppose any other digit comes B and C. So B and C is already present in this array, so it will not append any digit or any letter in this data structure. So this will prevent us in using more memory. Now suppose this comes A, D, E, R. So A previously is there, so it will just add a D, a E and a R. So this is all what it will add. Now suppose this come D, S, T. Now this D is there in the array. So this D is there in the array. So we'll continue from here only. We'll take a H and we'll take a T. So this is the try data structure. Now how this will help? First of all, it will help us to reduce our type complexity, and you can say it as a prefix data type, prefix tree, or prefix data type tree, or whatever you want to say it, but it just stores the prefix of n up to any digit. Now suppose you want to search a digit A, B, C. Now in this video I'm just going to explain this much only about try and searching part. I'll explain the coding also of that, but if you want to study in more detail, comment it down, or previously I have made one more video on try data structure. I'll give the link in the description, please check it out also. Now after this, suppose we want to find this ABC. Now what we will do, we'll go in the data structure, we'll go in the root. Now if root is equals to this, then we will call for this, we'll call for this, we'll call for this. So if any of this becomes 2, then further we will go. Now in this case, if this becomes 2, then we'll go in depth, so B, and then in the depth we can go to C. So we found our tree. Now if we found this B, sorry, let's check for D, H and T, DHT. So I want to search this. So first of all, what I'll do, H is not in this array. If it is there in the array, then also it does not make any difference. If it is there in the array, then we'll call some more things. In this case, we have to again call both the things. So we'll call both the things. So B will be called and D will be called. Now what is the digit of our first? D. So we will now further proceed in this direction. We will not proceed, sorry, we will proceed in this direction also, because further in this direction you can get any digit. So in this case we got D. Now we will call these both, and in this here we can call C. Now here we call C. Now we got our digit C. C is there in this array, must means C is the first digit, no, so we will go in this. So we will get a H, then we will call a T. So we have to go on each and every node so that we can easily traverse. Now this, if suppose dot comes, suppose dot HT. Now we will skip this dot and we'll consider a single digit in this code. This will be a very similar to a question which I have covered. The description will be in the link, but in that question this dot part or this search part is not, this dot search part is not there, other than the question is totally similar. Now we'll just directly see the code so that the confusion does not occur in this solution. For that, let's see our solution. So this is the data structure which we are going to make. The character C, first and next, which will point some pointers, a flag, and a constructor which will help us to construct some nodes. Now flag will store that our word exists till now or not. So default it was flag. Flag will be initially false only, first will be null, next will be null. Now the question only says that we have to define two functions. Sorry, we have to define three functions, one for the creation, second for the first for the creation, second for the add word, and third for the search word. Now first of all, we will first create a node which will be initialized with 0. This will be why I am initializing it with 0, so that our question may have some continuity. Suppose we have a digit A, B, C, and D, E, and F. Now these both does not have any similar point. So now where to begin, or in this case two different trees will be made. So we cannot afford that thing. So for that we are taking a 0, so that 0 will point this and 0 will point this. So this thing will be done with the easily help with this. Now we'll we'll understand that add word function. Now what it is doing, it is just calling a create function with word, 0 and root. Word will be the word which you are going to get, 0 will be the index of that word, or the root will be the main root node of this. Now let's see that what this create says. So first of all, this is a very simple function. It seems to be difficult, but it is very simple. So first of all, we have checked that index size is equals to 0, means in the word is complete till now or not. If the word is complete, then it will return us the flag of this value will be true. Now what this says, A, B, C. Now in between, suppose we are on A, B, so till now the flag will be of false of this node. So at this node, flag will be false and C will contain some value. Now after that, C will be initialized of index. C will be initialized with the value of index. Now two variables will be initialized, temp and pre. we'll just try to find out the values. So first of all, we will initialize the find that we found the value or not. If we found the value, we will proceed. Now from just points the root node. Now if root first is null, means if does not exist any value in the node, or sorry, we does not exist any digit or any value in the try data structure, then we will first add the first value and we will initialize this with the first. Now after that we will call this function create again with index plus 1. Now what this will do, it will just initialize store first value a, and then it will, the tied data structure will be again called with the next index of this tree, which we will make as from's first. Now after that, if we have on second or third value, then what we will do, we will initialize this temp, this temporary variable which will store the from's first, and we will create the find equals to false. Now what we are trying to do, suppose our try data structure is like this: a, b and c. So this is our data structure. Now what we are trying to find out, suppose we are on this index. Now we are trying to find out that we found our data structure means we are just trying to find out that our current value, suppose we are currently on D. Now we are trying to find out that D is there in this tree or not. If D is there in the tree, then we will make our node from there only. If it does not exist in there, then we have to make a new node from here. In this case it is not there, so we have to make a new node. So this will be done easily with the help of this code. So this will be done here and D. So this is very easy task, we can do this easily. Now if the index exists, so the find will be true there, means what we are trying to do, suppose we found here. Now our found will be true and we will go further. Now why if the find will be true, because till now we have find a word which will end us a correct word. So this makes our work easy in data structure to take that flag which will initialize all our variables. So find will be true. Now if find will be true, then parents next will be initialized with this, means if it has two variables, first is the first and second is next. So the next will be initialized with this value, this D. Suppose here a digit comes b and d, so this will be b, so the next value will be initialized with this. So this is the thing what we have to do in this code. So the main complex thing is to understand the data structure, that what it does. So if you do not got, again and again I am saying that if you does not got the data structure, please study my previous video. I have explained there it very properly or in detail, and if you does not get that properly, please comment it down. I'll make a new video on data structure properly. I'll explain there with the help of many examples. Now in this case I have make a try data structure in this. Now I just want to search in try data structure. Now creation is very easy in try data structure, so searching will be also easy. So for searching, first of all we have to initialize some things. Now first of all we have to initialize at this from. Now this from will point the node currently we are on. Now if front is null, in case front is null, then we will directly return false. Now what we are trying to do, suppose we are on some indexes, suppose this we have to find out a, b and c, and we have a tree this as a, b, d and c. We have this as our tree. Let's make it proper. So this is our tree, and here suppose we consider as O and P. Now we will start making the tree, or we will start searching. So first of all C will be stored in the index, so A will be C will be equals to A. Now temp will be created and find will be initially false. Now temp will be initialized with the from will be initially at 0th index. Now if C is a dot, then we will do something. If C is not a dot, then we'll do something. Now let's see what we have to do when C is equals to dot. So let's expand it. So this is the code which we will do when c is not c is equals to dot. Now suppose c is dot, then what we have to do, we have to traverse for all the digits, or sorry, for the all the possible values of a temp. So this we will do with the help of while loop, and then we will check that if index is equals to as dot size dot search minus, sorry, as dot size minus 1, which will be the size of this digit. So in this case it will be 2, it will be 3, but minus 1 it will be 2, and the index at the end will also be equals to 2. So this is the breaking condition. When this will be fine, then we'll return the temps flag. Now till now, if any digit exists, then it will return true, else it will return false. Now we are next thing what we are doing. Now if it is not next, then what we'll do, we'll call a new function with the help of this similar things as index, temp, and first. This is a standard what we say, this is a standard data structure traversing, and this is very simple to understand. Now after that, this is simple that if we done all these things, then we have to call for temps next, that what it will be. Now what we are trying to do, find out, suppose we are on this B. Now we have two directions, so we have to search for both. So this thing is done by this loop. So tries temps next will go on. Suppose here one more node is there, here one more node is there, more nodes are there. So first of all, this will go on this node, then this, then this, then this, then this. It will search for all the nodes, all the possible nodes which are possible till now. It will search for everyone. So this is for the dot. So similar is there for the what we say, if we found some word. So very similar, but a small difference it is there, that here in this case we does not require to compare anything, but in this case we require to compare. That is character is equals to c, then we have to return. If a dot is there, we does not require to compare this character. Now this is all about this question. Now if you have any confusion in the question, please comment it down, and a prerequisite for this question is try data structure. If you does not know about that, please go on the description, or go in the description and check the video which I have pinned there. Now I am just going to explain this much about try data structure. Now this question will be very simple if you know what is a try data structure. So let's check the time complexity. So this will be very less as my expectation. So this is up to 87. So this is very less time complexity as compared to many of them. It is up to 87% of what we say, 87% of the CPP submissions. So runtime is also not that much. It is 128 ms. So try data structure makes your work easy, so I recommend to study that. If you does not know about it, or if you want to know more about it, please comment it down. If any part of it you do not got, or if you do not understand any part of it, comment it down. I'll explain you there, or on that topic I'll make a new video. So for that, you please subscribe my channel, and for more such videos or for more such solutions of August Leetcode challenge, subscribe my channel, like the videos, share the videos, and comment down if you got nothing in this question, or if you got anything, please comment it down. Thank you guys.